In early 2026, the technology firm Block cut nearly half of its 10,000-person workforce. CEO Jack Dorsey was explicit about the reason. AI had made those roles unnecessary. He noted that within the year, the majority of companies would reach the exact same conclusion. The immediate incentive driving these executive decisions is highly straightforward. When a firm replaces a human worker with a capable AI agent, that individual firm captures 100% of the resulting labor cost savings. But these displaced workers are also consumers. When that lost income is not quickly replaced through reemployment or transfers, it removes active purchasing power from the market. Every round of automation cuts operating costs, but it simultaneously erodes the consumer demand that every firm relies on to generate revenue, which presents an economic contradiction. If the impending drop in aggregate demand is visible to everyone, why would rational, forward-looking firms continue racing toward the edge of a cliff? The answer requires us to stop viewing the AI transition as a simple labor market shock. We have to analyze it as a structural failure in the product market. The trap lies in what economists call a demand externality. The financial damage caused by laying off a worker does not stay isolated to the company that issued the pink slip. Because consumers buy goods and services from a wide variety of vendors, the demand destroyed by one firm's automation spreads across the entire sector. The spending contraction heavily impacts that firm's competitors. This leakage creates a mathematical disconnect between what is rational for an isolated company to do and what is optimal for the market as a whole. To see exactly how competitive markets lock firms into this destructive cycle, we can map their incentives using a task-based automation model. By isolating the variables, we can prove that transparency and perfect foresight are mathematically powerless to prevent over-automation. We establish a theoretical baseline by imagining a single monopoly firm that controls an entire sector's output and employs all of its workers. This equation block represents the firm's marginal profit function. The first variable, S, represents the per-task labor cost savings. This is the exact amount of money saved by automating a single human role. We subtract L, which is the effective demand loss per automated task. This measures the displaced worker's lost purchasing power that will no longer be spent at the firm. Finally, we subtract K alpha, which represents integration friction. Automating increasingly complex human tasks requires progressively more time, testing, and capital to implement. Setting this equation to 0 reveals the cooperative optimum. This is the precise rate of automation where the labor savings perfectly match the combined cost of the integration friction and the lost consumer demand. Because this monopolist controls the entire sector, it absorbs 100% of the demand loss it creates. The financial sting of firing its own customers acts as a natural brake. A unified market successfully balances the drive for cheaper labor against the preservation of consumer demand. Now we introduce competition. We fracture the monopoly into a set number of symmetric, competing firms, which we will call N. When one of these individual firms automates a task, it still captures all of the labor cost savings for itself, but the demand loss changes. Because the laid-off worker used to buy from everyone, the demand destruction is diluted. The firm only bears a fraction of the lost spending, represented here as L divided by N. The rest of the damage hits its rivals. The mathematical consequence is that the perceived financial penalty for automating drops drastically for the individual firm. Driven by this skewed incentive, the firm pushes its automation rate past the cooperative optimum to reach the Nash equilibrium. We can calculate the exact distance between the optimal rate and the competitive rate. This mathematical gap is the over-automation wedge. This creates a game-theoretic trap. Maximizing automation becomes a strictly dominant strategy. Every firm must aggressively replace workers to secure cost savings, because the resulting demand destruction will happen to them anyway when their rivals automate. In the frictionless limit, where AI is incredibly cheap and easy to integrate, the system devolves into a pure prisoner's dilemma. The rational outcome for the market is 100% human displacement. This heat map graphs how the wedge scales dynamically. As the number of competing firms increases along the x-axis, the over-automation distortion severely worsens. A monopoly, sitting at n equals 1, has a wedge of 0, but as the market fragments into dozens of competitors, The dilution effect maximizes the wedge. And as the operational cost of AI shrinks, the mathematical threshold for this trap expands to cover virtually any competitive market. Standard economic intuition suggests that increased competition protects a market. Here, competition is exactly what drives firms faster over the demand cliff. It is common to assume that AI automation simply transfers wealth from the working class to the capital-owning class. The math proves otherwise. This graph plots total worker income against total owner surplus. The sweeping curve is the factor payoff frontier, representing the possible economic outcomes. The cooperative optimum sits at the peak of the curve. This is the maximum combined efficiency for the economy. But the competitive Nash equilibrium plots strictly southwest of that optimal point. This drop is absolute deadweight loss. Over-automation erodes aggregate demand so severely that total firm profits shrink right alongside worker income. Both owners and workers strictly lose. Which raises a question. What if we introduce highly productive AI, systems that generate significantly more output than the humans they replace? More capable AI triggers a secondary race for market share. Each firm automates faster to capture the extra output. But because every firm adopts the same technology, the market share gains cancel out symmetrically across the sector, leaving only a wider over-automation wedge in their wake. The layoff trap is a lose-lose scenario. Building structurally superior AI does not solve the demand problem, it amplifies the damage. If the market mechanism cannot self-correct, we have to look at external policy. How do you close the over-automation wedge? We can use the wedge equation as a diagnostic tool to test the exact mechanics of popular economic interventions. Take universal basic income. A UBI injects autonomous demand into the economy, which raises the baseline profit level for all firms. But UBI mathematically fails to close the wedge. It changes the total profit floor, but it does not change the marginal cost savings of replacing a specific worker with software. The incentive to fire remains untouched. What about a flat tax on capital income? A profit tax multiplies the firm's total end-of-year profit by a flat scalar fraction. Because this tax scales uniformly across the entire profit function, it cancels out in the firm's first-order math. The automation margin is identical, and the wedge remains perfectly intact. Even if firms attempt private co-say bargaining, sitting down to voluntarily agree on automation limits, the pact fails. Because over-automation is a strictly dominant strategy, any voluntary agreement is mathematically unenforceable. Cheating the pact is too profitable. Any policy that simply adjusts total profit levels will fail. Solving the trap requires a tool that directly alters the per-task margin of automation. To fix the mechanism, an intervention must precisely charge the firm for the external demand destruction it forces onto everyone else. This requires a Pigouvian automation tax. Unlike a profit tax, this is a per-unit charge levied specifically on the adoption of an automated task. We set the exact rate of the tax to equal the fraction of the demand loss that the individual firm does not internalize. This aligns the firm's private labor savings with the macroeconomic social cost. The financial penalty is restored, and the over-automation wedge closes back to the cooperative optimum. There is also a dynamic benefit. If the revenue from this tax is used to fund worker retraining, it raises the overall income replacement rate. Displaced workers secure new roles faster, which organically shrinks the baseline demand loss over time. Treating AI-driven layoffs purely as a labor market issue guarantees failure. It is a structural product market externality. We have to regulate it as one to keep the competitive economy from destroying its own foundation.